All right, in today's notes, we're going to learn about compound events and probability trees. So let's start by defining what a compound event is. A compound event is an event made up of two or more events that can happen at the same time or one after another. Now, so far in probability, we've been talking about single events. You roll a dice. What's the probability that you get a 3? The event is rolling a 3. But let's say you had multicolored dice, and they were all drawn out of a hat. They were green, blue, and white, and you reached in blindly and grabbed one, and you needed to grab one with a 1 up. And so what's the probability of grabbing a green 1? Well, that's a compound event now, because first you needed to grab the green one, and second of all, it needed to have the number 1 facing up. So that would be an example of a compound event. A tree diagram uses branches, as you might expect, to represent different combinations or outcomes. Earlier this year, we learned to make factor trees. These are going to look somewhat similar. I think you will get a hang of it pretty quickly. So we're going to use an example. Everybody likes to talk about pizza. So for example A, we're going to imagine that we're going to go order a pizza. So we have 3 options for size. For size, we can get a small, a medium, or a large. Then we have 2 options for crusts, thick or thin crust. And let's just say it's a kind of a simple pizza shop without a ton of options. So we've got pepperoni and combo, let's say Hawaiian, and maybe the special this month is a kitten pizza. All right, so obviously you go into a real pizza place, you're going to have a lot more options. You'll probably have extra large and personal and stuffed crust, and then any number of combinations of toppings. So we're going to keep life simple here for us for right now and work with these options. All right, so I want to find out how many different combinations of pizzas can you purchase when you go in there. So we're going to set it up this way. First, we have choice 1. Choice 1 is size. I can get a small or a medium or a large. Those are my 3 choices. Then I have choice 2. That's the crust. So I can get a thick or a thin. So I could have picked a small pizza and then I could have a thick or a thin. Or I could have picked a medium pizza. And once I pick medium, I can still decide between thick and thin crust. And likewise with large. Thick and thin. Okay? Then I have a third choice to make. What type of pizza do I want? So I'm not going to write the whole words out. I'll write a P for pepperoni, a C for combo, an H for Hawaiian, and a K for kittens. Okay, so I'm going to just draw lines down here. And then, of course, so I could have gotten a small, thick crust pizza with pepperoni, combo, Hawaiian, or kittens. So I'm just going to go ahead and put all those options in here. P, C, H, K. You guys do the same on your diagrams, please. So that represents all three of the choices that we had in building our pizza when we go to buy one. First, we got to choose the size, then the type of crust, and then the types of toppings, right? Now, if we want to know how many outcomes in total there are, well, we can just count the end states, right? So this would be like a small, thick crust kitten pizza, and this would be a small, thin crust combo pizza, and a medium, thick crust pepperoni, and so forth. These all, the ends of the branches represent the number of unique combinations that you have. So if I wanted to just see, well, what one is this one? Well, that's a large pizza with a thick crust and Hawaiian topping. And every single one of these end states at the end of the branches represent a different combination. So it's as simple as counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4. There are 24 possible outcomes. Or combinations. Now, some of you probably already see the shortcut, that we don't have to count the end results. We can simply take the number of choices we had each step along the way, and we can multiply them. Right? We had 3 sizes, and we multiply each size by 2 choices of crust. Now I've got 6 total combinations. And then each of those 6 gets an additional 4 choices of toppings. So we're going to multiply the 6 by 4, and we get 24. In fact, the way you find out the number of combinations is to multiply the number of choices you have each step along the way. 3 sizes, 2 crusts, 4 toppings. 3 times 2 is 6 times 4 is 24. 24 possible combinations. Okay. Now let's look at how we can use a diagram like this to solve for some other probabilities. Let's say we were going to put all these combinations into a hat, and we're going to randomly draw our size and our crust and our toppings. Okay? So what's the probability then that I would get a thin crust pizza? Well, we can use our diagram first of all and count how many are thin. Well, that's these 4, 1, 2, 3, 4, and these 4, 1, 2, 3, 4, and these 4, 1, 2, 3, 4. So that's a total of 12 out of 24. So 12 out of 24 of the final pizzas came through the thin crust branch of the tree. This simplifies to 1 out of 2, or 50%. Now, some of you may have already picked up on the fact that we don't actually have to count all those. In fact, all we had to do is just look at the crusts only. Right? The probability of thin crusts, well, there's only 2 options for crust. So out of the 2 options, one of them is thin, and we go straight to 50% that way. Let's look at another example. What's the probability that I get a small pepperoni pizza? All right, well, we can use our tree diagram first of all. So we know we have to be on this small branch. So we're only looking at this part of the tree diagram. And then we need a small pepperoni. Now notice the crust didn't matter. So there's a small pepperoni right here. It has a thick crust. And a small pepperoni right here. It has a thin crust. So there are 2 small pepperonis out of how many total combinations are represented here? Out of 24. That simplifies to 1 over 12. You can either do the long division or type it into your calculator. 1 divided by 12, and you get 8.3%. Now let's see if there's a shortcut for us instead of building a tree diagram and counting. So probability that you get a small pepperoni. We're going to look at each choice individually. The first choice was about size. So small. How many smalls are there compared to the choices of sizes? There is 1 small for 3 sizes. Okay. Then what's our next choice? Topping. How many pepperonis are there out of all the possible toppings? Well, there's 4 possible toppings, and 1 of them are pepperoni. So notice if you multiply your first choice by your next choice, you get 1/12, which is the same exact thing that we had when we used the diagram and counted the actual outcomes. And so we get 8.3% again. All right. And let's do one more. What's the probability that you get a thin crust kitten or Hawaiian pizza? Okay, well, let's start with the diagram. So thin crust kitten or Hawaiian. So the size doesn't matter. So we know we have to follow all three of these thin crust branches. So thin crust kitten or Hawaiian, there's 2 here. 1, 2. There's 2 here, 3, 4, and there's 2 here, 5, 6. There are 6 total pizzas that are either kitten or Hawaiian and are thin crust. So 6 out of 24, that's a 1 out of 4 chance when you simplify it, or 25%. Now, if we hadn't drawn the whole tree diagram, we're hoping for an easier way as well. And so I'm just going to break it there. First, the probability of drawing a thin. Well, there's 1 thin out of 2 options. Then what's the probability of getting a kitten or a Hawaiian? Well, there's 4 toppings total, and kitten and Hawaiian represents 2 out of those 4. Okay. So we've got 2 out of 8 simplifies to 1 out of 4, which is a 25% chance. So this, you notice we did not need a tree diagram to do the calculations here on the right. Your classwork tomorrow is going to ask you sometimes to use the tree diagram and sometimes not, where you can use a shortcut. So I encourage you to, if this didn't quite click, make sure that your notes are good. Check the scanned-in version to make sure that your notes are complete, and maybe listen to the video a second time just to make sure you're tracking with how to find the number of combinations using a tree diagram, and how the tree diagram really represents simple multiplication math steps that we can use to find the probabilities without drawing an entire diagram. And I hope you have a good day in class tomorrow.